Hello, we are going to do some examples. How this works is I do notes and then sometimes I give you practice problems. And for the first part, I'm going to have videos on these practice problems so you can see someone doing it with you. And then after that, you are going to slowly do them on your own, and then we're going to take off our training wheels. But until then, here's an extra video. Sometimes you get to your homework and you don't know how to do your homework, or you get to the classwork and you don't know how to do the classwork. And these kind of videos that we go through problems, like practice problems, is really helpful. So this is a continuation from our notes with Unit 2, Lesson 2. If you didn't take notes on that, go back and take notes on that. But we're going to work on the problems, the exercises, the examples. Those are all different ways that I'm going to call these types of problems. So in your notebook, maybe you took notes, you did your Cornell notes, you did your summary, and then you are going to try practice problems. So you would write student exercises, or you can write examples. If you're copying this from the notebook, you're going to write examples, because then a teacher will give you the example. Use tape diagrams to solve the following problem. 3m is equal to 21. So my 3m's, I have one piece of tape that is 3m's, M, M, and M. Okay? Then I have another piece of tape that's equal to 21. So I'm going to use a tape diagram for this. Tape diagram. And now I think to myself, okay, if this whole thing is 21 and there's 3 parts here, then I have to think to myself, what would M be? If I solved for M, I would divide 21 by 3 to undo 3 times M. So you think, okay, what would fit in this box where if there was 3 of them, it would make 21. So logically, M would equal to 7. This is not with algebra. This is just like with a tape diagram, a model, because that's what the directions say, tape diagram. Let me continue to highlight. If you need to pause here to catch up, pause, and then I'll meet you in the next problem. The next problem is to solve the problem algebraically. So using your good reading strategies, you know to identify words that mean action words. So this says solve. So this means we're going to isolate N. If you want to pause the video to write down the problem, because I'm annotating this, so you may want to do that as well, as in do that. So under solve, you know that's going to translate to isolate the variable. Algebraically means no tape diagrams, use inverse operations. Inverse operations. So you have 15 equals n over 5. I'm going to use my scratch work side here. Scratch work. Scratch. So on your notebook, maybe instead of like a big ideas column, then you just put your scratch work there. So my scratch work is over here. N over 5, well, that's equal to 1/5 times n over 1, which is equal to 1/5 times n. This is in case you wanted a step-by-step of how I broke that down. So if this is n divided by 5, I need to multiply 5. I need to multiply 5 on both sides in order to undo n divided by 5. So let's see. This is n divided by 5. So the inverse, we need to multiply. So I'm just going to copy down the problem here. I haven't changed anything. I just actually need more room. So I'm going to multiply by 5 over 1, 5 over 1. So 5 times 15, that's 50. That's 75 over 1, because I multiplied. When you multiply fractions, you multiply the numerators across and you multiply the denominators across. Okay. Same with multiplying these fractions, then you get 5 times n over 5, and this will make a big 1. You'll get 75 is equal to n. That's how you do it algebraically. Let's do 2 more examples. I'll pick up the pace a little bit. Calculate the solution. If you need to pause here and write down this question number 3, pause here and write down this question because I'm going to annotate next. Hopefully you wrote down the question. Calculate the solution. Okay, calculate the solution. So this means isolate P of the equation using your method of choice. I'll do both. You don't have to do both. I will do both. 4P equals 36. And then this is 4P equals 36. Okay, tape diagrams. Here we go. 4P, this one. So 4 of them, huh? All right. So this is P. This is also P. This is my variable, and it's going to equal to my right-hand side. So these should be the same length. And this is 36. And if I think to myself, okay, I need to also split it up into 4 pieces. So I need to divide 36 by 4. That's 9. 9, 9, 9, 9. If I do 4 times 9, I get 36. If I do 9 plus 9 plus 9 plus 9, I also get 36. So that means P must equal to 9. That's my tape diagram. Let me do it algebraically. Algebraically, this is 4 times P. So I need to divide. So how do I undo multiplication? Oh, I divide. So I'm going to divide by 4, divide by 4. This becomes a big 1. 4 over 4 is equal to 1, right? So this becomes a big 1. 36 divided by 4 is 9. Same answer. I like both methods. I like this method to model when I'm stuck, and I like this method when I'm being really efficient and fluent. Let's do one more example. In your problem, in your notebooks, all right, you're going to write down example number 4, and then we're going to read this together. So pause, write it down, and then unpause. Welcome back. Examine the tape diagram below. I am examining the tape diagram below. Examine the tape diagram below. Write an equation it represents. Okay, that means I have to write an equation. Something equals something. Then calculate the solution. So this is step 1. Okay, step 1. Write an equation. Step 2, calculate the solution of the equation. I have 3 steps because I'm going to do, I don't need to do tape method. They already did it. This says my first tape, 70, is going to equal my second tape, because they're the same length, 1, 2, 3, 4, 5, 6, 7. 7 Qs. Okay. So then I'm going to calculate. This first way, I'm going to divide. This is 7 times Q. So I'm going to divide by 7 and divide by 7 on both sides. So this will be 1Q, big 1 right here. Q, and this is equal to 10. That's cool. Now I'm going to do this. Yay, tape diagrams. I'm going to split it up into 7 parts. And I think 70 times what? If this whole thing is 70, if I split into 7 parts, how many is going to be in each of these boxes? Oh yeah, 10. So each Q is equal to 10. Check. Woo. Okay. If you need to summarize the most important parts, if you had questions on any of these examples, that's where you put a star, or maybe you're like, I don't know how to do this part, and you put an exclamation point with a triangle. That means caution, watch out. And when you come to class, when your teacher comes around to stamp, she looks at this and she's like, oh, maybe we need help with this question. So that's it. Goodbye.